All right, for this afternoon, this is our topic, DC to DC converters. Under ani nga topic tong na mention na to tong first na to nga week, no, the types of DC converters. Under ani ang buck converter, boost converter, buck boost converter, and shook converter. Okay. So for this afternoon, we'll start with the buck and the boost converters only. So modern electronic systems require high quality, small, lightweight, reliable, and efficient power supplies. So when you say power supply, kuan di ba, AC to DC converter or rectifier, no? Rectifier circuits. Linear power regulators whose principle of operation is based on a voltage or current divider are inefficient. We've proven this before. I don't know if you still remember. Sa mga components ka ni. Yeah, normal voltage divider circuits, Zener diode circuits, pure transistors used as voltage or used as switch alone are inefficient in themselves. Ato nga na-compute before sa akong pagkadumdum. Na-compute na to ilang efficiencies, mabutog mga 50%, no? Why? Because ang the voltage that is lost, no, they lost ang term. The voltage nga ilahang gi-divide is converted into heat, no, dissipated into heat. So kaning nga mga klase nga converters, ilahang mga gi-divide na voltages are dissipated to heat. So if 50% ang efficiency, yan ng mga converters, if 50% ang ilahang efficiency, so 50% of the power is converted or lost to heat. So hindi na mo atong objective when we use either step up or step down converters. So example, simple lang gud nga kuan. Circuit, simple nga voltage divider circuit. What if 10 volts ni siya? Then both of these has equal resistances. So we expect na 5 volts dire and na 5 volts here. So what if ang requirements sa atong next step nga circuit is kani, no? 5 volts. Now we could do this. We could connect a voltage divider circuit directly to our next circuit. But katulad then again, 50% of the power is already lost to heat, dissipated by the resistors. So ang katong lost na current magamit unta sa atong next na circuit is sayang, no, dili niya magamit. Nawala na to heat. So there are other ways, and one of it is to use DC to DC converters. So these are examples of what a modular DC to DC converter look like, no? Kung nagipangwas somewhere. Pwede po ta makabuhat og atong own, no, nga DC to DC converter. So may mga uses ani. So solar power, no? So output sa photovoltaic. Ang output sa photovoltaic cells kay DC. DC. So what if di man natin makontrol ang voltage drop or voltage potential ng output sa solar panel, direct kanang direct niya nga output, no, dili na to di ta kabuot, no, pila voltage na. So what if is larger, or what if we want a larger requirement nga mas gamay ang output sa solar panel? So we need an intermediary, which is a DC to DC converter. It may step up or step down the voltage output. No? Think of this one as a DC na equivalent to transformers. No? So transformers could actually, depende sa design, either step up, di ba? Or step down the output voltage. Kung 100 volts ni, pwedeng output is 50. No? Or pwede gapon 200. So yung step up. So that's how transformers operate. So how does a transformer do it? So if this is a lossless na transformer, idea lang. If this is a 100 volt, and for example, 1 amp lang ni siya na transformer, nga AC supply, if yung step up to times 2, munaog po ang kuan, no? Ang current, no? So na trade off. That's what happens to transformer. Bali, the same kung step down transformer siya. If this becomes 50 volts sa output, 2 amps iyahang current here, no? So these are ideal conditions nga transformer. So conceptually, in the same way nga nagyapon ang DC to DC converters, no? If we have one thing nga atong matiman-an sa atong kaninga discussion, that DC to DC converters work the same way, no, as a transformer. So nagya po trade-off, no? So DC ang iyahang input. So let's say this is a DC to DC converter. And yan yung conventional nga way pag draw in block diagram form sa DC to DC converter. No, kung dili necessary mabalaan ato mabalaan sa circuit sa sulod. So the same gamo sa transformer. If natay 10 volts here na ga-supply og 1 amperes, then even if let's say this is a lossless na DC to DC converter, no, there's no such thing as that magyud, pero we could design a DC to DC converter as close as that. So if 5 volts lang ang output here, no, ni half siya, expect nga ang ampere is mo times 2. So naikuan, no, mo nang trade off. And again, the opposite is also true. If ato na design in such a way nga 20 volts ang output, expect nga ang output nga current is na divide po into 2. So yan na, no? Power in, power out. Without considering losses, P is equal to PO yun, no? So conceptually speaking, no, that's how DC to DC converters work. It either steps up or steps down a DC source. Then ang trade-off is ang current. Pero if this is a step down, no, converter, I would say nga win-win situation siya, no? For one thing, nakuha na to ang we obtained a lower value na required voltage. And number 2, na-boost pag ang current, no, na multiply pag yun. Okay, if i-step down na tong voltage, mo step up ang current. Yan na maganda, no? That's a trade-off. So win-win siya sa boost, sa back, no, back converter or step down converter, because nakuha na nato ang required na voltage level. Sisaka pag ang current. So the main areas of application of these converters is at low power level. Their main area of application is low power levels as low dropout voltage regulator. Switching regulators use power electronics semiconductor switches in the on and off state. So later, when we encounter DC to DC converter circuits, isa sa iyahang major part na component is the switch, no? Which is modeled as such. Nga. But it should be noted, nga dili gid na siya mechanical switch ato ibutang dia. But it could be a power electronic device, no? Pwede siya thyristor. Okay? Pwede gyapon transistor, no? Power BJT or power MOSFET. Okay? Sige lang, ako lang I think balikon na gyapon ako ni later. So the functions of a DC converter are stated as follows: to convert a DC input into a DC output, to regulate the DC output voltage against load and line variations, for which a normal regulator cannot do, reduce the AC voltage ripple on the DC voltage below the required level, provide isolation between the input and the load. This could be done in many ways. So DC converter is another way to do it. Another way is op-amp. Pwede naman ma-perform using op-amp. Pero op-amps may not be feasible for high-power applications. Protect the supplied system and the input source from EMI, electromagnetic interference. I think mo go hand in hand ding duha. Isolate, kailangan mo ma-isolate para i-protect mo from EMI. And satisfy various international and national safety standards. So it provides a added safety measure. Magbutang tag intermediary na DC to DC converter. Okay. So first, before we go further sa usual types or most common types of converters like buck and boost, ato sa i-cover ni DC choppers, the building blocks of more common DC to DC converters, so DC choppers. So the circuit on the right is an example of a DC chopper for which ang load is RL. RL siya nga circuit. Kaning E, this may model back voltage, BAC back voltage lang or negative voltage drop kibali, nga posible kaunon pod sa load. So ang kanang RLE nga circuit sa load nga side is model lagi po na siyang any type of load. So wala yung giingon earlier, sa kaning nga circuit and for future DC to DC converter circuits, ang gigamit nga is symbol is ang mechanical nga switch. Pero dili gid siya mechanical nga switch atong i-connect. Okay? Again, this only generalizes whatever power electronic device nga to i-connect here. We could connect here a thyristor, SCR, or we could connect a BJT or a power MOSFET. Okay, so yan na siya. Kaning switch here, this only simplifies the circuit. Hide niya away ang actual na power electronic device. And kani pagid nga switch is wala nagibutang dire ang kuan. Ang gate kung MOSFET man or base nga driver circuit. So here it's possible na napay mas complicated pagid nga circuit here that drives our MOSFET or our power electronic device which acts as the switch, or it could be as simple as an ECE, AC. It's as simple as an AC na source. And square wave. Pulse with modulated na pulse with modulator na input. Yan na. So the DC to DC converters that follow kay generally nga ni gid ang kuan, switching. It is fed or the switch is operated using a pulse width modulated na signal. Yan na. Okay. So, if pulse width modulator ni, we know na if on ang signal, on po datong switch. Kung off ang signal, off po datong switch. So that's how it works, man. We've covered that before. So the switch is being operated with a duty ratio or duty cycle. This could also be termed as duty cycle. Some sources state duty cycle. It is the active portion of the period of the input signal as the ratio of the switch on to the sum of the on and off. So here, duty ratio or duty cycle D is equal to the time that it is on divided by the time it is on plus the time it is off. And we know that the sum of the time that it is on and off is equal to the period itself. So for example, muna itong pulse width modulated na signal. So this is one period. So our period is divided into two. Here and here. So this is T1, this is T2. Let's say, for example, it is on at 1 millisecond, and this is off at 2 milliseconds. So ihang period is 3 milliseconds. Yung duty cycle is 0.33. If I'm not mistaken, 1 plus 2 is 3, so 1 over 3, 0.33 ang duty cycle. So this has a duty cycle of 0.33. Yan na. So for a DC chopper, the output voltage will be, or the average output voltage is equal to the duty cycle times the input voltage Vs. Yan na. So simple lang siyang equation. So the average output voltage is always smaller than the input voltage. Hence the name of the converter. So DC chopper. Chop niya off ang voltage into two parts. The load voltage and current are graphed under assumption that kanino, this is the general assumption for all DC to DC converters, that the load current never reaches zero and the load time constant tau computed by using this formula L over R in terms of second mas yun yung tau. So this is time is much greater than the period. Okay. So tau if I'm not mistaken, tau is the time sa pag-discharge. Ano ko ng kuan sa tawag ni inductor, yung response. Yeah, so this is tau. So tau should be much greater than the period. Okay, if mas taas ang period, let's say for example, mas taas lugar ang period kaysa sa tau, ang inductor is na-discharge na, naabot na siya zero, wala pa nahuman ang input signal. So, dili na siya mo atong gusto, no? So, what we want is ang period sa atong signal is much less than, so yung period, no? Period is less than the time constant. So important that we know how to compute the inductance, L. Average values of the output voltage and current can be adjusted by changing the duty ratio. So, dahil na kayo siya i-operate man, if we want, given man yung VS, given ang input voltage. So, if we want nga ma-divide into 2, let's say 10 volts ang given, then we want a 5 volt na output. So, dapat i-operate na to ang pulse width modulator here, ang switch ha, ang input signal at 50%, 0.5. So, dahil okay siya. So, it's just a matter of designing the input signal nga mag-drive sa atong switch or sa atong power electronic device. Okay, technically, there's not much to design naman sa DC chopper or even sa buck or boost converter kay defined naman gina sila ng mga circuits. Although there are improvement or more complex designs for, let's say, for example, for buck converters or even for boost converters, na pa may kaning ma-discuss nato later, these are the simplest of the buck converters. Let's say, for example, kanina sa slide. No? Those are the simplest of the circuits. Those are the simplest buck converter circuits that exist. So but there are improvements to that one, that require more components. Siguro ang ilahang use is mas ma-improve ang behavior, ang operation sa pag-convert o DC signal. But still, again, those circuits are predefined na. No? So, the key thing lang here is ang pag-define nato sa duty cycle. And dito na siya sa switching circuit natong design. So, notice here sa atong sa atong graph. So, if the period is larger than what appears here, supposedly munaog pagid ni siya. Munaog. But, ito lang period na to is this one. Nisaka na po siya before it can even go down. So, that's what happens if ato i-hook up og oscilloscope ang atong circuit. Okay. So, this DC chopper is, again, the basic building block for buck and boost converters. So, kung ato lang ning i-tweak gamay, this is the circuit for the buck converter. So, nalang tayo gibutang diri nga capacitor here. Series man silang duha, so ato lang silang i-switch og position, then butang ta og capacitor here. Yan na. Napamagyan pa itong snubber nga diode. So, this that allows our DC chopper to become a buck converter. Wala. So, sa kayong operations sa buck converter, again, operations-wise lang, it's not very complicated. Defined naman po ang circuit. Waveform pa lang daan, we know what's happening. So, how does a buck converter work then? Or how does it convert? So, back siya, no? So, step down. So, mga natong timanan, doon alam magkikaklase nga DC to DC converter, back and boost. So, kung boost, pangalan pa lang sa converter daan, boost. So, i-step up niya. So, when you say buck converter, it's a step down converter. So, how does it step down the value of the input DC voltage? No? So, from 10 volts, it's possible nga maabot ng 5 volts na lang here, 50%. No? So how does it do that? 50% duty cycle. So duty cycle sa switch is 0.5. Ayan na. Pero ang circuit operation niya is something like this. Okay? So when the circuit is off, okay, when the circuit is on, okay, so when the circuit is on, current will flow from the source to the circuit. This charges, no? This is charge ang proper nga term, capacitor mo na siya. This allows the inductor to store energy. Okay? And current now will flow to the resistor. So may tabo sa on nga part sa period sa atong input signal. So during off, what happens is, so kung off, open circuit na siya, so no current will flow. So this is an open circuit at T2. So if open circuit, mo flow pagyapon ang current because of this diode right here. So i-allow niya ang current mo flow in this direction. In operation pagyapon ng atong inductor. So our assumption must hold na dapat ang inductor will not turn off or dili siya mautan og current kibali, no? So di siya mautan og current, so it will continue to current will continue to flow up until mo na pud balik ang atong switch at the positive portion sa duty cycle. So on na pud siya, so wala na po yung current nga mag-flow sa diode, current mag-flow na pud here. Ayan na. So VL, or the voltage across the inductor, will reach, magilay siya capacitor, no? Ang charge nga term is capacitor naman magamit. The voltage across the inductor will reach the amount na kung pila ang i-chop off sa atong circuit. So balik ko sa akong example kanina. So if 10 volts here, kung sa to i-divide into 5 volts, so 5 volts ang i-reach nga voltage ni inductor. Ayan na. So in that case, step down gituod ang voltage sa atong output. So 5 volts na siya, or mas lower na siya nga value compared sa input. So that's how buck converters work, no? Kung nagid kayo kanang easy. Simple. Simple to keep track. So typical waveforms in the converter are shown again under assumption that the inductor current is always positive. When the switch is off, meaning when the switch is off, diode will turn on. That will keep the current in the inductor always positive. Diba? So kung off na ni siya, Mo-flow pa gyapon ang current because of this diode light here, allowing the current through the inductor to always be positive. So the state of the converter in which the inductor current is never zero, for any time period is called the continuous conduction mode. So common siya nga term for DC to DC converters, the continuous conduction mode. So how do we choose values for our inductors and capacitor? The formulas there could be used. The inductance can be computed by 1 minus D times R divided by 2 times F, where F is equal to the reciprocal of the period. So, dependent ang voltage drop across sa inductor, of course, inductance. And ang inductance is dependent sa duty cycle. Okay. The capacitance must be greater than this value. Okay. This is the value for the minimum capacitance. Compute gyapon. 1 minus D VO. VO is the value na atong required divided by 8 VR LF squared. F is frequency. L is inductance. VR, so ng VR voltage. Ripple voltage. Okay, ripple voltage in VR. Okay. So sa graph, so the same kanina sa DC, the same kanina sa DC chopper. For the positive portion sa VS minus VO. Yeah, VL. No? So the positive portion sa input, current sa inductor will rise. And sa negative portion, mag-go down siya. So, walang yung kanina, na kung taas lang nga itong period, and we don't want that, munawag pag na siya indefinite. Munawag pag na siya, until mabot siya 0. No? Again, we don't want that to happen. So, we need a smaller value of T, or a larger value of tau, time constant, L over R. So the larger the value of the inductor, the better. So that's for the buck converter. So the boost converter here, almost pareha gid siya og operation sa buck converter. If we understand buck converters, it's not difficult for us to understand also boost converters. Ang medyo, kung ako pa-define nun, mag-reverse niya ng operation, no? Mag-reverse. Kani, ang buck converter is kung on ang switch, well, na may current kin mag-flow sa diode, sa inductor at all times, kaya mamaya itong gusto. Kanina lang, kung off ang switch, kung on si switch, off si diode, kung off si switch, on si diode. No? So, ang effect niya na is, mas step down ng voltage. Here, bali. No? Kung off si switch, same liga po, no? Kung off si switch, like sa circuit, on si diode. Kaya kung on is si switch, off man si diode, kaya di naman mag-flow ang current. So, reverse, sabi? Parehas sila lagi. Parehas sila. Baylo lang ang position sa mga components. Gibaylo ang position sa switch, sa inductor, sa diode. So instead nga na-add ang diode earlier naman dito. Na-add ang switch. And na-add ang inductor. So baylo sila. No? For what purpose? Para ang purpose is ma-step up ang voltage. So again, this switch could possibly be a power electronic device fed with a pulse width modulated na signal. Okay? So na-time on, na-siya time off. So sa first time nga on siya, okay, so sa first time nga on, of course, current will flow in this manner. Okay? Dili pod. Ang flow na siya sa capacitor. Charge ang capacitor. So that's the first time nga on si off ang switch. Okay? So kung on ang switch here, yung na to ang input. T1. Pero ang period lang ani is T1 to T2 lang T1 and T3 are equal in magnitude. So sa first instance, T1, again, current will flow in this direction. So at T2, when the switch is on, so when the switch is on, wala na current mag-flow here, na-cut off na sila because dili na mawagi ang current. Dili mawagi ang current. Okay? It allows the voltage drop sa atong inductor to reverse polarity. So, plus minus na siya. No? Plus minus. This is during T2. So, sa next na po nga cycle, sa next nga on, sa T3, meaning off na po na atong switch, okay? Current will flow here na, back sa original. Pero, if atong i-analyze the voltage drop nga ma-measure ni load, nisaka ng voltage drop. It's Vs plus, okay, para sa mas like polarity, VL. No? So, na-boost tuod, no, or ni-step up ang voltage drop across the load. Step up. So what I just described is gyapon nang describe sa waveform, na converter waveforms in sa ning CCM continuous conduction mode are presented when the switch S is in the on state. The current in the boost inductor increases linearly. The current increases. So the diode is off at that time. So the switch is turned off, the energy stored in the inductor is released to the diode to the input RC circuit. So napagyapoy, of course, kung on ang switch here. Yeah. Kung on ang switch here, may purpose nga diode. So kung on nga switch, diba na-cut off na nga initial na current. Na-cut off na siya. Kaya dito naman na mag-flow ang current ni inductor. Dito naman mag-flow. So mag-discharge si capacitor. If wala ni si diode, si capacitor is i-discharge niya ang iyang current padlong dito. No? So we don't want that to happen. So muna purpose ani nga diode para i-block niya ang discharge current ni capacitor. So during on state sa switch, current will just flow here. No? When the switch is turned off, the energy stored in the inductor is released to the diode. So the constant constant. Ganina, this is how we compute for the output voltage, no? Directly multiply the duty cycle by the input. For the boost converter, muna yung formula nga i-multiply sa input, no? So kung akong i-rewrite, this is just equal to VO is equal to 1 minus 1 over 1 minus D Vs. Wala, may gayon nga 0 CD. Diba? So the denominator is always, okay, so the larger the D, now the larger the D, so let's say na to 0.9 eh. So 1 minus 0.9, so that's 0.1. Mas dako si V, mas dako nga conversion factor. But if this all is still is just 0.1, so 0.9 ni siya. So mas gamay. But still, in any case, VO will be always greater than VS. In any case, no, VO is greater than VS. Kasi unsa pa kagamay or dako si D. Kaya di magina ma-0 si D. That's impossible. Kaya kung 0 si D, 1 over 1 lang na siya. So VO equal to VS. May times na kung si D, no? 0. So mas larger nga D, mas better. Yeah. The larger the duty cycle, the better. The larger the duty cycle, the larger the output voltage. Kay dire, the larger the duty cycle, the larger mapulang VO. Pero VO will always be less than VS in any case. Here VO is greater than VS. So the same sa buck converter. Nagyapoy formulas for computing the inductance and capacitance na requirements. So factor gapon or dependent gapon sila, or it's a function of the duty cycle. So duty cycle gid ang key thing here. Okay? And dito naman nato na vary ang duty cycle sa ato pag-design sa atong driver circuit sa atong power electronic device. Yan na. Sa duty cycle sa pulse width modulator. Kaya wala naman kayo tayo ma-design kita ani. Choose lang na to ang value for capacitor inductor. Pero mo naman gini ang circuit sa boost converter, even buck converter. Define lang mga circuit. All right. Any questions? Sa inyo no? Sa inyo lang ilang operation? Pwede kita makabuhat og atong own nga buck ug boost converter sa balay gamit breadboard. Basic naman sa mga component. Bisag mechanical switch ron eh. Bisag tuod kuan na ni siya kanang sa tawag na kanang push button switch nga kita ra mag-manual on off. Pwede ta makabuhat og atong buck or boost converter sa kuan, no? Breadboard. So may sense kung yan na, di ba? Yeah, di siya considered noon nga amplifier. Sige daw. So may, that's a good question, no? Good question. Kaya ako compare earlier ang buck converter to, or ang DC chopper to a transformer, for which pala lagi sila og concept. AC lang ang transformer, DC lang eh. Pero ang amplifier, ano kaha, no? Yeah, for one thing, ang amplifier is AC signal man ang i-feed na to sa amplifier, no? Ato i-feed sa amplifier na to is AC signal nga naa sa mga millivolts nga range para mustaka siya towards aning range volts. Ang amplifier pod it's possible nga ang power output sa power sa output signal is mas greater sa power sa input because ang ato biyang amplifier is manginahanglan og help sa external nga DC na source. So possible gyud kaayo nga ang output sa amplifier is greater than input. But for the DC to DC converter, ideal condition, output equals input. Realistically, power is still less than input. Yan na. May trade-off. May yang i-trade-off sa for ideal conditions, PO is equal to PI kay ni naog tuod or in this case ni saka tuod ang VO pero ninaog ang current compared sa current nga mo flow sa input, no? Yan na. So yes, dili siya technically ma-consider ang amplifier because ang amplifier yang use is a boost. Boost gyapon ang gamit nga term, no? I-boost niya ang voltage level sa input signal. Ano no? Dili siguro boost gid ang term kay kung boost mong good malala mag-imong gi-clamp, no? Pwede man good nga iyan yung input then iyan yung output. So imo lang gi-clamp. So yan na ang converter, no? Strictly speaking. Pero ang amplifier is dili biya. Ang amplifier is gamay gid siya kanya mong gipadako, no? So imo gyung I think mo gid ang technical term gi-amplify nimong signal, no? Okay, so okay, gets. And kani yeah, for the most part ang application lang gid sa DC sa converters kay nalagid sa kuan, no, nagid sa switching or sa industrial applications. Dili ka siya di ko na makita ang yung use kung signal gid ang i-feed sa iyaha like ECE lugar ibutang diri, no, or sound signal. So nagid sa for industrial applications. So almost all DC machinery will require gid og converters in some form. Na mga buck boost converters sa Canon, no, sa cars, sa mga appliances kan ay mga DC nga load like DC motors, heaters, yan na. Showers, katong shower nga na heater, no. Ang usa ang inverter. DC to DC to AC may inverter. Ang converter kay DC to DC man. Yeah. Okay. So, any more questions? Sabtan na ba? Wala to, no? Medyo ang slides nga ito available kaya ganda kaig mga details o mga waveforms. Pero malagid to, no? Malagid to ang purposes sa back-end boost converter. Intermediary siya or interface. Kibali, interface siya for two systems. So, ang pinaka no, common nga nato ma-observe sa mga kitag DC to DC converter is if natay solar nga power system and nadi atong mga appliances load, no? Di nato dito i-connect ang appliances ug load sa atong solar power. But napala siya intermediary. Ana. Nayuban nga mag-term niya solar system. Alib mo. Makuha na noon ko, no? Kailangan akong mandumduman kong solar system. Yan na. Last Facebook, tingnan ko na nato isa ka training So, daw pag-design ng solar system. Solar power system. Kasi sila lang pasabot. Take naman ang term na solar system. So, solar power system, dito ilang pasabot. Okay. So, isa ato, no? Isa sa module ato nga seminar is kani converters. Okay, any questions? Ako lang i-upload ni nga slide sa e-learn para na may copy. But if there are none, this ends our discussion on these converters, part 1 this afternoon. So part 2 next meeting. Ang saman mo, naki-question. Ano naman di ay sa back converter. Sa may pares. Front. Back. Kuan, maguding ka back, manggod. Di ba back man eh? Ang pares ani kay do converter. Tama na eh. Di ba? Milwaukee Bucks. Any more less educational questions? Sama sa chicken. Say back chicken. So, pasagot ni mo job. Bok. It's sad yun ko. Mura na yung madumduman ha. At least nanamoy ka ng sa tawag ani ka ng anak ka ng ma-relate. Kasi day nani sa board exam, di ba? Back converter. Hello, so itong back converter, katumantong pang pa-step down, di ba? Katumantong na-execute may og, di ba? Though a deer, a female. Sige na. Stop na. Wala na more meaningful questions. Sige, wala na. Break sa 5 minutes. Balik ta by 3 o'clock sa Pikas na room for logic. Okay? Bye-bye. Pang snack sa mo. Kapag wala pa paniod to sa mo.
Bye, sir.
Bye-bye.
Sir.